So first I write down. Okay, so then how do we answer the second question? How far downstream can she travel? Scott?
You substitute the D for 1/2.
That's right. You substitute. Do you think I should substitute 30 or half for D? Half. What happens if I plug in 30? What would that mean? 30 hours. Okay, so please be careful. So maybe you should just not write 30 minutes, but half an hour to, not mess it up. Because what if you blindly plug in 30, right? So you're going to plug in half to which one? 5D or 3 minus D? Do I plug in D to 5D or 3 minus D? After all, aren't these the distance that we travel? Which one do I plug in D for? Either one. Why, Anita? It's a round trip, so I should get the same answer either if I plug into 5D or 3 minus D. Isn't that right? As you can see, that what's 5 times half? 2.5. What's 3 minus half? 2.5, right? You better be same, otherwise you did something wrong, right? So what would you write as your answer? Yes?
It takes 30 minutes to go downstream, and it takes 2 hours and 30 minutes to go upstream.
No, it's not 2 hours and 30 minutes. It's 2.5 miles.
Oh,
When you plug in D for the distance, you get the distance, right?
Yeah.
I mean, D for the time, sorry. When you plug in D for the time, you get the, right? Rate times time gives you the distance. So 2.5 is not the hours, it's the miles that she traveled. Does that make sense? So that means she went down 2.5 miles, and she came back up 2.5 miles. Does that make sense? Of course, it took her longer, right? It took her, how many hours did it take her to go back? Like, to go upstreams, it took her 2.5 hours, but still. Okay, any question? Yes.
This was round trips.
That question. That's a very good question, Barry. Barry says, wait a minute. Wasn't the first and the second one, both of those examples, weren't they all round trip? How come we didn't let the distance, how come, let's go back. Why didn't we then let these two, the distance, why didn't we do, yeah, go back. Why didn't we do 3 times r plus w equal to 5 times r minus w? Why didn't we do that for the second and the first and the second one? Who can answer that question? Yeah, because we did it here. How come we didn't do it for the first two? Why didn't we equate the two distances together? Because they're all round trip. Why didn't we do that? Courtney.
There were 2 different variables.
Yeah, we had 2 different variables in them. Then that will mean that you're going to get one equation with 2 variables, which means you can't solve. That's why we used the information that was given. So depending on the kind of information that was given, right, we got it. So that's why we had to use, because they gave us the distance. So you got to, equate those with the distance, and you get 2 equations with 2 variables. That way you can solve. That's a very good question. Okay. So yeah, sometimes you want to just equate these two. For example, here you just have 1 variable. So then you could equate them together. The other ones, they had 2 variables. Okay. So you can't, okay? Question?
You could have made that a different variable, though, right? Like 3 minus D, you could have made that like another variable.
Yeah, you could. But yeah, since it was simple enough, yeah, I just used 1 variable. They're right. So I could have actually done this problem, example 3, with using 2 variables. But since I knew that, but we've done this so many times, right? The whole time it takes 3 hours. Yeah, you could have done one for time going downstream, the other one for coming down, but so and then you use substitution. Basically, that's what you're doing, okay? Right. So, what are your unknowns? First of all, do you know what's going on? No. Okay. So we got a boat going downstream. How far is it going down? 72 kilometers. Now it says it takes same amount of time as it takes to travel how much? 48 kilometers upstream. Does that make sense? No. Why does it not? Okay, look. If you're going downstream, like for example for 1 hour, let's say you went on downstream 1 hour and you went 72 kilometers, right? Right? And if you go back up 1 hour, you would travel shorter amount of distance. Why? Because what? It takes longer to go upstream. Isn't that right? So does that make sense? That's what they're saying. So you look at the difference here. Is this a round trip? No, it is not. They're saying that they're traveling same amount of time to either go upstream and downstream. And if you're going same amount of time for downstream, who's going to go longer? Who will travel farther down? If you're going downstream or upstream? Downstream. That's why they go 72 kilometers here, going downstream, right, for same amount of time. And when you go upstream the same amount of time, you go 48 kilometers. Does this make sense?
Yes.
It doesn't?
It does.
What are the 2 variables? Alex.
The time
The time what?
The time you're traveling?
No, because, oh yes, the time you travel. You're right. The time you travel is what? Same for both, isn't that right? And we also need to know the rate of the boat in still water. Isn't that right, guys? Would you agree? Yes? The t represents the time it takes me to go downstream and also go upstream. Am I not traveling same amount of time? Yes, guys? All right, so write this down. Who could explain why the time is same for both, going up and down? Yeah, Will?
Because it says the same amount.
Yeah, it says right here. Right? Downstream in the same amount of time as it takes go upstream. Right, guys? So I could represent T for the time going downstream and T for time going upstream. That's why the distance is different. You see what I mean? Okay, let's fill in the chart. Go ahead, everybody go ahead and fill in the chart. I'll give you time. Tell me the rate, please. Downstream. 72 is the distance, isn't it?
Yeah, but you go 72 kilometers per
Yeah, that's for downstream and upstream. Wouldn't it be 72 over half of t?
No. What's the rate for downstream? How fast is the water, guys? 4. So, and I'm going, how fast am I going? My boat. It's to R. So what's the downstream speed? R plus 4. What's the up speed? R minus 4? Yes? Guys, this is not that hard, is it? Okay. Now, what about then time? Do we know the time for downstream time? No, that's why we declared this variable. What is the time for downstream? T. What about upstream? Okay, what's the distance? R plus 4 times T. And then what about the upstream time? I mean, distance. Yeah, R minus 4. Now, Liam, should I equate these two together? No, because we have two variables. You can't do that because only you get only one equation with two variables. So then we need to come up with two equations. Do we know the distance for downstream? Hello? What is it? Hint, hint? Yeah. What is the distance for upstream? 48 makes sense. It's shorter, right? Because you're going against the stream. So there are the two equations. Any question? Pretty straightforward. Okay. I really wanted to go over this question because you will see this on your homework. And because it's something that involves, we're gonna get some equation where you have to be careful in solving these, doing addition method. Okay, so first of all, could I simplify these as much? Are these already simplified? Can you simplify any further? No, you can't. So I'm going to just distribute t. Is that okay? So I'm going to distribute t in both cases. Now, I get tr plus 4t equals 72. TR minus 4t equals 48, right? Now, I'm going to use addition method, right? Yes, I am. But do you think I should get rid of 4t or TR? I have a choice. How many people say TR? Raise your hand. Okay, good. How many people say just get rid of 4t because it's nicely set up? And you get 2 TR and then you add them together? No. The answer is you want to get rid of TR. Why do we want to get rid of TR? This is really important. That's why I wanted to. Why do we want to get rid of TR, not 4t? Who can answer? Aram.
Because if you take out the 4t, you still have 2.
That's right. If I get rid of the 4t, I would end up getting one equation with how many variables? 2. Does that help you solve for the variable? No, it does not. So guess what? We have to get rid of the TR. How do I get rid of TR? Can I do that right now? No, multiply the second one by -1. Okay? So when you do, right, don't you get TR plus 4t equals 72 and then negative TR plus 4t equals negative 48? Right? Now, guess what we're going to do? Are we ready to add? Yeah, do you see how we want to get rid of the TRs? Okay, you don't want to, right? In this way, you will get one equation with how many variable? 1. Would you not get 8t equals 24? Do you see why I wanted to go over this question? Because if you get rid of 4t, because it's nicely set up for addition, right in the very beginning, you will not be able to solve the equation. Okay? you would not be able to get the solution. So then what's t, guys? 8t is equal to 3. Okay, now hold on, let me finish. Then if t is equal to 3, what do they ask you? Do they ask for the t? No, they ask you what is the rate of the boat in still water? So if I know the time, how do I get the rate of the boat? You use one of the equation. Could I use this one? T times r plus 4 equals 72. So you plug in t as what? 3. When you do, you could divide both sides by 3. You get r plus t equals to 24. What is the rate, guys? 20. There it is. The rate of the boat in still water is 20 kilometers per hour. Do you see how it's important to get rid of the TR? Okay. Guys, you're right. You could get rid of the t in the beginning and get TR equals some number, but then you'd have to substitute it back in. It's a lot longer. You want to get an equation, right? This is faster, isn't that right? You want to get an equation with one variable, so you can get this a lot faster than doing it the other way, okay? So there you go. Here's your homework, okay?